Hello, my name is Cecilia Rivas, and I'm a junior at Trinity Washington University. This past summer, I conducted research with Dr. Cassiano Negroni and Ms. Nichols at Trinity Washington University to see if we could detect undeclared caffeine in weight loss teas using reverse phase high performance liquid chromatography. A little bit of background is that in the United States, the Food and Drug Administration classifies weight loss supplements as foods and not as medications, which makes them less regulated. The FDA has conducted tests on these weight loss supplements and has found many dangerous chemicals in them, such as phenolphthalein and sibutramine. Also, with the rising trend in detox and weight loss teas, caffeine is an ingredient that consumers should be aware of. Many teas contain naturally occurring caffeine found in the herbal ingredients listed on the label. However, because caffeine is naturally occurring, manufacturers are not required to claim the presence of caffeine. It is important to screen these weight loss teas because of the negative impacts the consumer can gain from these products. So in terms of our methodology, the first step we did in our experiment was to analyze a list published by the FDA that contained weight loss supplements marketed as unsafe from 2009 to 2023. From this, we found, as shown in Figure 2A, that the trend of weight loss supplements flagged had an increase until 2015, but afterwards started decreasing tremendously. From the FDA data, we also found, as shown in Figure 2B, that mostly all of the weight loss supplements flagged as unsafe or synthetic, while some were marketed as natural, even while containing dangerous chemicals. Figure 2C displays the percentage of dangerous chemicals found in these weight loss supplements. Among the most common dangerous chemicals found were sibutramine and phenolphthalein. Our next step was randomly purchasing teas from around the Baltimore, Washington area. 9 teas were analyzed and screened using reverse phase HPLC. We were able to detect undeclared caffeine in 3 of the 9 teas that were analyzed. Figure 3A displays our caffeine standard, which shows that if caffeine is detected in any of the teas, then a peak should appear between 3.5 and 4 minutes. And as you can see, 3 peaks from 3 different teas appear. In terms of the detection of phenolphthalein, no phenolphthalein was detected in any of the teas. Figure 3B displays a chromatogram with the phenolphthalein standard, which has a peak at 3 minutes. So if phenolphthalein were to be present in any of the teas, a peak should appear at this time. However, it is shown for example, with tea number 3, that no peaks formed, so no phenolphthalein was present in any of the teas or in this tea specifically. Figure 4 displays the calibration curve used to find the concentration of caffeine in teas. Table 2 displays an analysis of caffeine detected in the 3 teas. The concentrations of caffeine range from 8.6 to 317.98 milligrams per liters. The label of each tea claimed to be natural and did not state caffeine on the label. From this experiment, we were able to find that the most common adulterants found in the FDA list consisted of phenolphthalein and sibutramine. We found that there was a decrease in the detection of adulterants over the years, which could be due to an increase in FDA enforcement. We also found that more products containing dangerous chemicals were synthetic as opposed to those labeled as natural. Caffeine was detected in 3 of the 9 teas, and no phenolphthalein was detected in any of the weight loss teas. The concentration of caffeine varied in each trial due to it being naturally occurring. The amount of caffeine depended on how much was in the plant listed as an ingredient. Following FDA policies, naturally occurring caffeine does not have to be stated on the label. However, it should be stated on the label because individuals who are taking medications might also consume these teas without knowing that there is caffeine present. This can cause the consumer to have negative effects or reactions. To prevent this to prevent this from occurring, manufacturers should include caffeine in the labels to alert consumers so that they can be aware of the presence of caffeine. From this, we created an independent laboratory activity for chemistry students to receive hands-on experience with HPLC, learn to quantify caffeine in teas, and to be aware of ingredients in teas. We have successfully ran this experiment in an organic chemistry course. We also plan on analyzing these teas using liquid chromatography mass spectroscopy. I would like to thank NASA DC Space Consortium for funding. Thank you.